490, 491. We're going to do this one in one long apologies video. I do recommend maybe listen a little bit, skip forward a little bit, listen, skip forward, listen, skip forward, okay? And then at the end, I'll try to show you everything, but if it's not very clear, then do what you got to do with this video to help it be helpful for you. It is a proof video, and while I love proofs and I think they're fantastic, it took me a while to get there, and if you're not on my level, you gotta get on my level. But I'm gonna be where you are for the level you're at and try to help you through it, okay? You have previously constructed three medians of a triangle to determine the point of concurrency called the centroid. That's such a good word. Centroid. And points of concurrency, and that would be this location in the triangle right there. Follow the steps to prove that the medians of a triangle meet at this point, and you will demonstrate that the line segment from the third vertex that passes through the point C is a median. Given the triangle is there, it's XYZ, and there are medians XB and ZA, and they intersect at point C. Now, I don't see a point C here. Let's put that in the diagram. C. Prove the three medians of a triangle are concurrent. So we have a given, which is what we're going to start off with, and then we're going to have a prove. And so the reason why I'm doing this video all in one shot for 2 pages is because on page 491, the final step is the thing that we have to prove. And fortunately for us in the design of this problem, all they're asking us to do is come up with the reasons. And the reasons aren't bad. We've been seeing these reasons all the way throughout. So let's go with the first easiest reason. You got to get this reason when you do a proof. XB and I'm not sure why that of is there. ZA are medians that intersect at point C in the triangle. That is given. Now, because we have the word median, the word median tells us to do something, or something happened because of the word median. The next statement is relying on that vocabulary word. What does it mean for two sides to be medians? So I'm going to say definition of, I'm abbreviating it again as I do, definition is DEFN, definition of median. Okay, since this statement, statement 2, uses the word midpoint, then the next statement, XA and AY, that's these two sections right here, they are congruent, so spike and spike, because of the definition of midpoint. That vocabulary word becomes the vocabulary word of the next reason. And then we've seen this one when you've done your Mathia and you've done all of your online homework. These two, this is a congruent segment. This is now an equal measurement. This is called definition of congruent segments. And we've seen this one. If you've done it, if you've done your work, we've seen this one. Now it keeps going. We're going to say construct auxiliary lines to create triangles necessary to continue with the proof. So they created a line that goes through C and ends out here at E. And then they created a parallel line, XE, parallel to AZ. And then just connected it out again here, EZ, to make the third one. So these are the auxiliary lines, 3 of them that are created. And the reason for statement 5 is literally because we had to do it. There is a way to construct parallel lines, and there is a way to draw a line from one point to the next. This is literally by construction of auxiliary lines. Right? That's all. We're just constructing them. We're just making them happen. And this is one where I'm going to show you how to do it. I'm not going to test you on it, but I'm going to show you on it because knowing that trick, well, that's what separates the teacher from the student. Okay, next up, we have angles that are created. And I notice whenever we see parallel lines, reminder, parallel happens because of the arrows and the way that it was constructed. When we see parallel lines, we're probably going to have corresponding angles. So, angle YEX, that's Y, then E, then X. Ooh, let's bring in some color here. That angle has to be congruent to angle YCA. YCA here. They're corresponding angles. Corresponding angles in parallel lines are congruent. So corresponding angles in parallel lines are congruent. And for the same reason, I'm going to choose a different color pen now. I'm going to do the other one, EXY. So EXY, that's all of this, is congruent to CAY. So CAY, that's this one. There's a small little triangle right there and a big triangle out here. And the small triangle and the big triangle happen to be similar by angle-angle similarity. Okay, that is all of page 490. We are letting the statements be given to us, and we got to think about why a statement would exist. And just trust the 1, 2, 3, 4, step process, all the way down to 20. I'm going to bring in the next page. Establish that C is a midpoint of segment YE. Wait, where is YE located? YE is this one. Okay. And we're saying C is the midpoint. Now hold on. Because of triangle mid-segment theorem, we've created a dot that's, well, we've created a triangle that's half the size of the larger one. So yeah, that should be on the middle, but we have to be specific, explicit, and make sure that it is very clear why we get to say something. So a little rearrangement on my desk, just so I can make sure everything's all visible here. And now we have EC divided by CY equals AX divided by AY. That looks like parts of the triangle, and because we have a triangle that is similar to another one, this is the proportional sides theorem, or segments, proportional segments theorem. Then, if we say EC over CY equals XA over XA, that's true. That's right here. XA over AY, well, these are the same thing. So if we have a fraction that has XA over AY, we can just substitute. It is helpful to say it was step 4 that gave us the substitution. That way, anyone else reading this goes, oh, I can go back and look at step 4. Cool, cool, cool. Okay. By the way, XA divided by XA, that's a reduction to 1. So reduce fraction XA over XA to 1. Now, EC divided by CY equals 1. If you solve for EC by multiplying both sides by the denominator, CY, that is going to set up the fact that EC is going to be equal to CY. Therefore, by definition of congruence, if the measurements are the same, the segments are congruent. They have the same measure, so therefore they have to be congruent segments. Then last of all, C is the midpoint of EY. We're saying that these two line segments are equal, and if you know that those two line segments form a line, a longer line segment, and they're equal to each other, then they have to meet in the middle. So this is definition of midpoint. Okay. So next up, show that the quadrilateral EXCZ is a parallelogram. And we mean EXCZ. This shape right here is a parallelogram. Well, in order to do that, we've already established that we have mid-segments, and mid-segments create parallel, or are based upon half of the opposite side, but the opposite sides are parallel. So when we say that AC is a mid-segment of triangle XYE, XYE, this is a mid-segment. It's because, wait, where am I at here? AC right here. AC is a mid-segment because we already talked about it. We did this definition of mid-segments to get there. And then the other one, likewise, BC is a mid-segment of the other larger triangle, EZY, or they say YZE. Because of mid-segments create parallel sides. That's the triangle mid-segment theorem. That means because we have parallel sides, and parallel sides, here's parallel to here, here's parallel to here, so therefore we're able to say that the triangles are, the shape EXZCZ is a parallelogram by the definition of what a parallelogram is. Opposite sides in a parallelogram are parallel, and there's a section where two sides are parallel, and then all the way back, where'd it go? 5? By the way that we constructed it, by step 5 and by step 15, we have a parallelogram. Okay, we're down to our last 4 statements. Our last 4 statements to say the 3 medians of a triangle are concurrent, which is they cross in the same location. XD, so XD here, and ZD here are equal. That's because it's a diagonal and it's being intersected. This diagonal of the parallelogram is being intersected by this diagonal, EC. So diagonals bisect in parallelograms. You have that fact from before, which means if they're bisecting, then there's a point that is exactly in the middle. D. D is the midpoint. Definition of midpoint. Okay, so if D is the midpoint, then that makes YD a median. Because in the original triangle, without the auxiliary lines, in the original triangle, we have these 2 lines crossing at point C. If we can get the third to cross through there and cross at point C, then we have the idea of concurrency. Since D is a midpoint, YD is a median. Definition of median. And then last of all, if all 3 medians meet, you've identified a point of concurrency, and that point of concurrency is called a centroid. So we have all 3 of the medians actually do cross because of steps 1 through 19. If all of the medians cross, they make the centroid, and that means the 3 medians are concurrent. There we go. That is the entire proof. Thank you for watching this video on page 490 and 491 to demonstrate that if you have a triangle mid-segment, it can do stuff for us in other proofs that we've already explored. Intentionally, this is a long proof. I might ask you to take your notes that I gave you and write it up, but I won't ask you in a stressful setting on a test to go from start to finish. That would be brutal. Here is the entire picture of it all. Let's see if I can set that there. That's the document camera taking picture of everything. Let's do a little bit of an arrangement so you have the entire picture of all of it. And from start to finish, some focusing. And I'll get zoomed in here, zoom on in. One more focus just to see. It don't get much better than that, folks. So enjoy, and I will see you in the next episode.